Hello and welcome to Objective 5 Notes. This is going to be part 1 of our Objective 5 Notes. Objective 5 says I can solve a linear equation and identify the answer as one solution, no solution, or infinitely many solutions. Today we're going to focus on solving the linear equation. Now when we solve linear equations, it's our goal to isolate the variable of the equation. We want to get that variable all by itself so we can identify what it's equal to. Now when solving for a variable in any equation, we need to undo the operations on the variable. So this is kind of a different approach, because what we'll do is we'll actually do really the order of operations backwards, which is pretty cool, right? And normally when we're simplifying, we have this order of operations. Now we're going to undo all of those so that we can get x all by itself. So let's just dive into it and look at some examples here. Looking at letter A, negative 90 equals negative 5 times the quantity negative 2x plus 6. So normally what I do here is I distribute that negative 5, right? I distribute that in. We're actually not going to do that here. We're going to take a different approach. We're going to divide both sides by negative 5. That way we can undo that negative 5, right? Instead of multiplying out, we want to undo it. We want to do the division. All right, so a negative divided by a negative gives me a positive. 90 divided by 5 is 18. So 18 equals negative 2x plus 6. All right, now I got to get this x all by itself. So the first thing I'm going to do is I'm going to subtract 6. Remember, we're doing that order of operations backwards now. We're undoing them. So I'm going to say minus 6 here. 18 minus 6 is 12. So 12 will equal negative 2x. I divide by negative 2. Divide by negative 2. 12 divided by negative 2 is negative 6. Now I would say that x equals negative 6. And now the cool thing here is that I can plug this in and see if I get the correct answer. So I'm not going to make you do this for all of them, but I do think it's a good practice just to double check. If I plug in negative 6 for x, do I get a true statement? Negative 2 times negative 6 plus 6. So this time, let's follow the order of operations as we should. Does negative 90 equal, let's see, I'd have to do inside these parentheses first. So 12, or negative 2 times negative 6 gives me 12. 12 plus 6 is 18. So negative 5 times 18. As we said earlier, that is negative 90. So that checks out. And that's how we can check our answer to make sure we know what we're doing moving forward. All right. So let's look at letter B here, and I've kind of written all up in its space now. We'll try to divide this out a little bit better. All right, so looking at letter B, I'm going to start by, So notice how I have multiple variables here. So last time where I only had one, I could just divide everything by negative 5. In this case, I can't divide both by negative 7 and 3, so I am going to have to actually distribute these out here. So I'll distribute this 3 into everything. When I do that, I'd get 3 minus 9b. And now I'll distribute this negative 7 into everything, and I'd get negative 7 plus 7 times 6 is 42. 62. All right, now notice here, I'm going to combine these like terms. So I have 3 minus 7, so that'll give me negative 4. And then I also have negative 9b plus 42b. So I believe that will give me 33b. And that equals 62. All right, you see that? We just combined our like terms. We combined 3 and negative 7 to give us negative 4. Negative 9b plus 42b gives me 33b. All right, so now I'm going to add 4 to both sides. Add 4 here, add 4 here, and that tells me that 33b equals 66. Well, this will work out nicely now, because right now it's 33 times b. I need to undo that multiplication, so I'll divide. 66 divided by 33 is 2. So that means that b must equal 2. And there's my solution. All right. Let's try one more here. Let's try letter C. So I'm going to start by distributing this negative and this 7 into everything. So 7 times negative 7 is negative 49. 7 times 8n would be 56n. We'll say that equals a negative times 1 would be negative 1, negative 8n. The opposite of negative 8n would be positive 8n. Alright, now let's see here. What I'm going to do next is I'm going to get my n's on one side of the equation and my numbers on the other. So let's start by subtracting 8n from both sides. So I'll have negative 49. 56 minus 8 would be what, 48, right? So we'd have 48n equals negative 1. I can add 49 to both sides. Alright, okay, very good. So negative 49 plus 49 over here. Negative 1 plus 49 would give me 48. And I can divide by 48, and this is going to work out really nicely because any number divided by itself gives me 1. So I know that n must equal 1. Alright, raise your hands if you have any questions. I'm happy to come around and help out. Let's do a few more together here. Let's try letter D. Alright, so negative 105 equals 5 times 2n minus 5. So here's an example. We only have one quantity. We only have one set of parentheses here. And we're multiplying that set of parentheses by 5. So let's just go ahead and divide by this 5 here. Alright, now negative 105 divided by 5 is negative 21. Equals, and now we only have 2n minus 5 here. Alright, very nice. So we can add 5 here. We can add 5 here. Got to get this n all by itself, so we're going to undo this minus 5. Negative 21 plus 5 would be negative 16 equals 2n now. Alright, divide by 2, divide by 2. Negative 16 divided by 2 is negative 8, which means that n equals negative 8. Excellent. Alright, now letter E, another one with multiple quantities inside these parentheses. So I can't divide by negative 5 and negative 3, so I'm going to have to just distribute this out, and we're going to have to multiply it all out here. So I have 66 equals negative 5 times negative 4v would be positive 20v. Negative 5 times negative 7 would be positive 35. Negative 3 times positive 5 would give me a negative 15v. And negative 3 times negative 2 would be positive 6. Alright, so let's check what we got here. Let's combine our like terms on the right side. So I'd have 20v minus 15v. That would give me 5v. And then I have 35 plus 6. That would give me 41. So my goal now is to get v all by itself. So I got to undo this addition. So I'll subtract 41, and I'll subtract 41. 66 minus 41, that would give me 25. Alright, so 25 will equal 5v. I can divide by 5. I can divide by 5. And that tells me that v is going to equal 25 divided by 5, which is 5. Alright, let's try one more together here. Let's try letter F. So 4 plus 4 times the quantity 3n plus 5 equals 8 times the quantity n minus 5. So first thing I do here is I'm going to distribute that 4 and distribute that 8. We're going to get rid of these parentheses here. So I'll have 4 plus 4 times 3n would be 12n. 4 times 5 would be 20. And that's going to equal 8 times n, which is 8n, and 8 times negative 5, which is negative 40. Alright, let's combine our like terms on the left side of the equation. So we'll have 12n plus 24 equals 8n minus 40. And now, once again, my goal is going to be to get these variables on one side and the numbers on another. So I'm going to start by subtracting 8n from both sides. Alright, when I do that, I'd now have 4n on the left side, and I'd be left with just negative 40 on the right. Now I'm going to subtract 24 here. I'll subtract 24 here. So I'll have 4n equals negative 40 minus 24. That would be Goodness, negative 64. And I can divide by 4. I can divide by 4. And that would tell me that n's going to equal negative 64 divided by 4 is negative 16. So n will equal negative 16. All right. At this time, why don't you go ahead and try a few on your own. If you want to do one by one GH and J, that's fine. Or you can do all of GH and J, and then we'll check them together, okay? So go ahead and pause the video, try GH and J, and then we'll see how we do in just a sec. Alright, so let's go ahead and check how we did here. So first, what I would do here is I'd divide by negative 3. Now, if you distributed, that's okay. We could still get the correct answer. We might just do it in a different way. So when I divide negative 81 by negative 3, I believe I get 27 there. So 27 will equal what's left in my parentheses now, 4a plus 7. And I can subtract 7 from both sides because I need to undo that plus 7. So I'll get 20 equals 4a. And then divide by 4, divide by 4. So I will have 5 equals a, which means that a equals 5. And I write it like that just because it's more proper to have the variable on the left. And if you look at all the other ones we've done, that variable has been on the left. So in my final answer, I'll have a equals 5 there. Awesome. All right, let's see how we did on letter H. Looking at letter H here, I would start by distributing this 4 and distributing this negative 2 into everything. So 4 times 1 is 4. 4 times negative 3x is negative 12x. Negative 2 times 5 is negative 10. And negative 2 times negative 8x would be positive 16x. And that's going to equal negative 18. So let's combine our like terms on the left side here. So I have 4 minus 10, that would give me negative 6. And I have negative 12 plus 16, so that would give me positive 4x. Now that's going to equal negative 18. So I got to get this x all by itself, so I'll add 6. Add 6. When I do that, I get 4x equals negative 18 plus 6 is negative 12. I can then divide by 4, divide by 4. And I'll find that x equals negative 3. Fantastic. All right. Let's check out letter J here. Let's check out letter J. So when I'm looking at letter J, I see that there's variables on both sides of the equations. So this is going to be one where I need to get all my variables on one side and all the numbers on the other. So let's start by distributing this out here. So I'm going to distribute this 2 and this negative 2 into the parentheses. So we have 2 times negative 2. That'll give me negative 4. 2 times negative b would give me negative 2b. And that's going to equal negative 2 times b is negative 2b. Negative 2 times 2 is negative 4. And then this plus 6 is going to stay there. Alright, so now let's combine our like terms over here. So negative 4 minus 2b will equal negative 2b. Negative 4 plus 6 would be positive 2. And now I got to get my b's on the same side. So to undo this negative 2b, I'll add 2b. Whatever I do to one side, I got to do to the other. When I do that, I'll get negative 4. Wait a minute. Negative 2b plus 2b. Wouldn't that just give me 0? So this is going to be negative 4 plus 0 equals, and these I just undid, 2. So negative 4 equals 2? Well, that's not true. Huh. Notice, though, I don't think we did anything wrong. Oh, I know what this means. So if there's no variable anymore, this isn't true, which means that this is actually an example of no solution. Everything we've done so far has had one solution. This one doesn't. This is no solution. Let's talk about that a little bit more. Alright, so there's actually 3 possibilities when we are solving these equations. It's possible to have one solution, like we've seen. It's possible to have no solutions, or it's possible to have infinite solutions. And I've shown this in the graphs below if you look here. Alright, one solution occurs when we have two equations that touch at one point. All right. So most of the equations we did up above, if we were to graph both of these equations, they'd intersect at one point. However, no solutions is possible if our two equations actually represent parallel lines. All right. Now, what did we see when it looked like when they were parallel lines? We got an untrue statement. What do you think then happens here if there's infinite solutions where both graphs have, or both equations represent the same line on a graph? Well, that's when infinite solutions occur. So algebraically, we know there's one solution when we get x equals some number. Right? If we find x equals 2, well, there's that one solution, 2. Now, when there was no solutions, do you remember we got an untrue statement? All right, we got an untrue statement. So something like, what did we have up above? 2 equals -4, I think. -4 equals 2. That's what that would look like algebraically. All right, that's not true. -4 does not equal 2. That's how we know there's an untrue statement. Notice there's no variable here, right? No variable. Whenever we eliminate that variable, we'll either have no solutions or we'll have infinite solutions, right? If we have infinite solutions, we actually get a true statement. Now, a true statement would be something like 0 equals 0. That's a true statement. Yes, it does. Notice again, though, there's no variable. Anytime we eliminate the variable, we'll either have no solutions or infinite solutions. Now, if there's a variable left in our solution statement, then that's how we know we have one solution. All right, so let's talk about what those look like. Solve the following linear equations. Identify if there's one solution, no solution, or infinite solution. All right, let's start with letter A here. So letter A, not everything here is divisible by 5, so let's go ahead and multiply out that 5. So we'll have 5x plus 25 equals 24 plus 5x. Okay, well, I can subtract 5x from both sides. Try to get it. Oh, look what's going to happen here. 5x minus 5x is 0 plus 25 equals 24. 5x minus 5x is 0. So we have here, it's saying that 25 equals 24. That's a non-true statement with no variables. So an untrue statement with no variables, we know that this means no solutions. No solutions. Untrue statement, no variables. 25 does not equal 24. We know for sure then that this is no solutions. All right, what about letter B here? Let's start by distributing everything in here. So I'm going to have -4 times 6 is -24. -4 times 3n is -12n. And that equals -8 times -3n, that's 24n. And -8 times 3, let's see, that'd be -24, right? So let's start by, let's add 12n to both sides here. Let's get these n's all on the same side. So I'd have -24 equals 24n plus 12n would be 36n minus 24 here. All right, add 24, add 24. -24 plus 24 is just 0, so 0 equals 36n. Well, I haven't eliminated my variable, right? My variable is still in play here, so I'll divide by 36, divide by 36. 0 divided by anything is just 0. So that tells me that n equals 0. Now, that's not the number of solutions. We have a variable in this statement, so it means one solution. One solution here, right? N equals 0, that's my one solution. N has to be 0. It can't be anything else. All right, looking at letter C. Let's start by distributing all of this here. We got -2 to distribute. We got -4 to distribute. That right side of the equation looks good. -2 times 3x is -6x. -2 times -8 is +16. -4 times -4x would be, goodness, +16x. And negative 4 times 2 would be negative 8, and that's going to equal 8 plus 10x. Okay. Combine our like terms on the left side here. We have negative 6x plus 16x. That'd give me 10x. And we have 16 minus 8. That would give me 8. And that equals, my right side, 8 plus 10x. All right, let's get these variables on the same side. So we have minus 10x, minus 10x. Oh, I see what's going to happen here. 10x minus 10x is 0 plus 8 equals 8. 10x minus 10x is 0. So my final statement here is 8 equals 8. Okay, so this is a true statement with no variables. What does that mean? A true statement with no variables, if we look right above, true statement, no variables, infinite solutions. Infinite solutions. Fantastic. All right. Why don't you go ahead and try letters D, E, and F, and then we'll check those together. So go ahead and try D, E, and F. Go ahead and pause the video, and then we'll check those together. All right. Let's check how we did on D, E, and F here. So looking at letter D, there's actually a couple different ways you could approach this. I'm looking here, and I see that we have this negative 7 to distribute, which I imagine most of us did, but I want to show another way that you could have done it. You could actually divide both of these by negative 7. And now notice when you do that, you have to do both of these terms divided by negative 7. So negative 28 divided by negative 7 would become positive 4, and negative 7r divided by negative 7 would become positive r. And when I do that, I'm left with r plus 4. Now most of us can see where this is coming. We can clearly see that 4 plus r is the same as r plus 4. When I subtract r from both sides, I'm left with just 4 equals 4, which means what, right? That's a true statement with no variables, so that means that this is infinite solutions. Infinite solutions. These two equations represent the same line. Negative 28 minus 7r and negative 7 times r plus 4. If we were to graph those, represent the exact same line. All right, let's check in here. Looking at letter E, I'll start by distributing it into everything, and I have this negative I need to distribute as well. So I'll have negative 8 times n, that'll give me negative 8n. I'll have negative 8 times negative 4, that will give me positive 32. And that equals, distribute this negative, negative 5 minus 8n. All right, well, let's get these variables on the same side. So add 8n here. Uh-oh, I see what's going to happen. Negative 8n plus 8n is 0, plus 32 equals negative 5 plus negative 8n plus 8n is 0. All right, so we have 32 equals negative 5. We have no variables, but 32 does not equal negative 5, which means that this is no solutions. There's no value for x that we can, or in this case, there's no value for n that we can plug in and get a true statement. All right, last one here. Looking at letter F, let's see, we got 8b minus 4. You actually could divide all this by 4, but we're just going to go ahead and distribute this time. I think that'll be a little bit easier. All right, so we have 8b. Negative 4 times 2 is negative 8. Negative 4 times 6b would be negative 24b. And that's going to equal 4 times 1 is 4, and 4 times negative 5b is negative 20b. All right, so we have 8b minus 24b. Let's combine these like terms. That would give me negative 16b minus 8 equals 4 minus 20b. All right, let's get these b's on the same side. So I'm going to add 20b here. I'll add 20b, not to be confused with Cardi B. Negative 16b plus 20b. Negative 16 plus 20 would be positive 4, so I'd have positive 4b minus 8 equals 4, right? Because negative 20b plus 20b would cancel out there. So I'll add 8 here, add 8 here. So I got 4b equals 4 plus 8 is 12. To get b all by itself, I divide by 4, divide by 4. 12 divided by 4 is 3. So that tells me that b equals 3. And there's a variable equal to one value, so this is one solution. All right, b equals 3. Fantastic. All right, we got 3 more problems and then we'll be done for the day. Why don't you go ahead and try G, H, and J, and then we'll check those together, okay? Go ahead and pause the video, try G, H, and J, and then we'll check those together. All right, let's go ahead and check how we did here for letter G, H, and J. So looking at letter G, I'd start by distributing this -8 and this 4 into everything here. When I do that, I'd get -4. And then I'd have -8 times 1 would give me -8. -4 times -4x would be positive, let's see, -8 times -4x would be positive 32x equals 4 times -3 is -12. 4 times -x is -4x. So combining my like terms here, I'd have -4 minus 8, so that'd give me -12 plus 32x equals -12 minus 4x. Awesome. So let's get our variables all on one side. I'll add 4x, add 4x. When I do that now, I have -12 plus 32 plus 4 is 36x equals -12. Now I got to get my numbers on the other, so add 12, add 12. So 36x equals -12 plus 12 is just 0. Alright, so this isn't no solution, remember, because we still have our variable. I can divide by 36. 0 divided by anything is what? Just 0. So x equals 0. There's my solution, and that is just one solution, right? One solution, x equals 0. Awesome. Let's check out letter H. So when I distribute this -4, I can put that there, and now I'm going to have to distribute this guy too. Alright, so -4 times n is -4n. -4 times 8 is positive 32, and that's going to equal 8. -4 times n is -4n, and then -4 times -6 would be positive 24. Alright, so I'll have -4n plus 32 equals, combine my like terms on the right, 8 plus 24 is 32. So this will be -4n plus 32. Oh, I see what's happening here. Notice right here, you can actually stop your algebra right here if you wanted, because -4n plus 32 is the exact same as -4n plus 32, right? These two equations represent the same line, which means what? Right? This is going to be infinite solutions, right? If you wanted to continue, you could add 4n. Add 4n. When you do that, you'd get 0. You'd be left with just 32 equals 32. That's a true statement. No variables, just numbers. True statement, which means indeed infinite solutions. Infinite solutions. Very nice. All right. Last one. Looking at letter J here. 8 plus 4 times the quantity 1 minus 3x equals 2 times -6x plus 8. Alright, let's see here. I'll start by distributing this 4 and this 2 into everything. When I do that, I get 8 plus 4 times 1 is 4. 4 times -3x is -12x. And that's going to equal 2 times -6x is -12x. And 2 times 8 is 16. So 8 plus 4 is 12. So I have 12 minus 12x equals -12x plus 16. Let's start by getting these variables all on the left side. So to undo -12x, I'd need positive 12x. So I add 12x to both sides. Oh, look what's going to happen here. -12x plus 12x will be 0. So I'll have 12 plus 0 equals, this side's undone, so I'm left with just 16 here. Well, 12 equals 16. No, it doesn't. Notice we don't have any variables. This is not a true statement, so that means that this one is indeed no solutions. Alright, raise your hand if you have any questions. Raise your hand regardless so I can get you these practice problems. Let me know how you're feeling though. This was a tough lesson, and I want to make sure we're all on the same page and good to move forward, alright? So this will be where we stop today, but I will see you next time where we'll finish our Objective 5 notes. And this is Mr. Carter signing off.